Hello there, my name is Heidi Biggs, and I'm presenting Alternatives to Agrilogistics, Designing for Ecological Thinking on behalf of my co-authors Tejaswini Joshi, Ries Murphy, Jeffrey Bardzell, and Shaowen Bardzell. This work was funded by NSF grants 1908-135 and 1900-722. And as this research has to do with the lands of Indiana, we wish to acknowledge and honor the Miami, Delaware, Potawatomi, and Shawnee people on whose ancestral homelands and resources Indiana was built. This paper explores a paradox in agriculture as it relates to climate change, and asks how we as HCI researchers might help disentangle this paradox in the design of agricultural technologies. The paradox is thus: on the one hand, agriculture is a major contributor to climate change. From farm to plate, our food system is responsible for 44 to 57% of anthropogenic greenhouse gas emissions. While on the other hand, contemporary intensified agriculture practices make agricultural production vulnerable to climate change. According to research by Purdue University, Indiana farms are more specialized and larger than in the past, making them more vulnerable to climate-related risk. We wondered how agricultural technologies might be designed to disentangle agriculture from climate change. So we conducted ethnographies with alternative agricultural practitioners and their conservation communities in Indianapolis, Indiana. We then analyzed our findings through the lens of ecological posthuman philosopher Timothy Morton's concept of agrilogistics, discussed in his book Dark Ecology. And agrilogistics, according to Morton, is an ontological logics of agriculture that separates agriculture from nature and which forms a basis for culture-nature divides. Morton and others agree that this nature-culture divide has led to the Anthropocene era, which is defined as the current geological era where humans are the leading cause of geologic change on Earth. This comparative framework, where we use theory to frame our ethnography, helped us define different agricultural ontologies between small farmers and Morton's agrilogistics. We found small farmers refute agrilogistics and are actively engaging with issues of climate change and climate resilience, and we offer ways to design like small farmers, suggesting we might transfer their sustainable and climate resilient ontological orientations to agricultural technology. This paper intersects with a long line of studying agriculture in sustainable HCI, as well as an emerging ecologically posthuman agenda in sustainable HCI, where scholars have studied ways to decenter the human in design and acknowledge more than human others. We continue these lines of thinking with a more specific focus on the ontological underpinnings of agriculture and ensuing connections to climate change. In the following, we will share our findings, framing our fieldwork with the agrilogistic framework. We introduced the 3 agrilogistic axioms which Morton suggests comprise agrilogistics, explaining them in turn, followed by a comparative analysis between that axiom and our empirical findings. Ultimately, we find that small farmers' practices and values often refute and challenge a purely agrilogistic view of agriculture. So the first axiom of agrilogistics states that non-contradiction is inviolable. And this is actually pretty straightforward. Non-contradiction is a fancy way of saying two contradictory statements cannot be both true at the same time in the same sense. So, for example, if something is not in the agricultural project, like a bug or a weed, it cannot be seen as part of the agricultural project, and this creates a strict binary. However, this type of argument ignores an excluded middle. And acknowledging an excluded middle suggests that sometimes there are gray zones where either-or logic isn't true. In the case of agriculture and ecology, there are quite necessary gray zones, or middles to include, that we need for sustainable agriculture to take place. So in our first findings section, titled From Pest to Helpers, the Included Middle, we compare small farming soil practices with the first axiom of agrilogistics. Talking with local conservationists, we learned cover crops and no-till farming are used to heal and transform soil quality. Keeping roots in the ground via cover crops is a way to add nutrients back to soil, allow a microbiome to flourish, and sequester carbon in the soil. Conservationists also have strategies for teaching people about the benefits of these techniques, like illustrative pit digs and soil demos, and this is sort of an image of comparative soil from 2 different pits dug in 2 different fields. For example, a soil conservation expert gushed over the good soil quality of a pit dug in an established no-till field, stating, "You can see the layers of compaction, earthworms in there, grubs, not to mention nodules for different nutrients and stuff on all the roots. It's insane." This information is then translated into tools. In this photo, we show tools used by a small production farm designed not to disrupt the soil microbiome. Left and center are photos of a tool which only fluffs the top few inches of soil to leave lower levels undisturbed, and on the right is a broad fork that gently aerates the soil without turning it over, which would disturb the microbiome. In this way, small farmers widen the aperture of non-human beings considered within the agricultural project, including the excluded metal, by cultivating soil health over longer-term timelines. Morton's second axiom of agrilogistics suggests that things which are in the agricultural project are always available and conditionless. If you took soil, for example, this would mean soil would remain the same regardless of how it was treated. This, of course, is not true. So in our second finding section, seeds as posthuman technology, we contrast the axiom of constant presence with seed saving. A soil conservationist first framed seeds as technology, saying, "You don't have to have a computer. Seeds are my technology. Seeds grow into a biological animal, just churning soil health and nutrients and water quality." But we extended this definition. At the Circle City Seed Swap, we met seed savers who cultivate heirloom seeds. In this photo, we show a huge diversity of seeds farmers brought to the event. While industrial agriculture sees seeds as a yearly commodity to be purchased, seed savers collect seeds which are passed down from mentors and family members, preserving biodiversity and local histories. Then, at the Indiana Small Farm Conference, seed saver Ben Cohen gave a talk about how seed saving allows farmers to selectively cultivate plants which are the most delicious and hardy, promoting the potentials of a plant through saving the seeds year over year. So instead of seeing seeds as conditionless, these farmers showcased how one can cultivate meaningful conditions of seeds, propagating hardy plants, preserving biodiversity, and collecting local, collaborative human-non-human histories. Finally, the third axiom of agrilogistics states that existing is always better than any quality of existing. In other words, more people are better than happier people. But in our third finding section, we noticed small farmers use their farming practices to mend quality of life, which we refer to as a metabolic quality, where good food and farming practices are metabolized to create stronger communities. Small farmer and co-op owner Cindy Feldman claims she farms to feed people good food. And urban production farmer Allie Moore claims her favorite part of farming is making connections in the community. Another small farmer, Amy Bennett, runs her farm to teach youth, often from disadvantaged backgrounds, about science. This photo shows one of the meeting spaces at her farm with the basics of science colorfully on display. By giving youth space to be, as well as ask and answer their own scientific questions, Bennett notes that students switch from survival mindsets to mindsets that foster agency and curiosity, which spreads to issues of community building. Small farming builds community through food and supports innovative, grassroots solutions to systemic problems. In our discussion, we draw out ways in which technology might be designed to support the agricultural ontologies offered by small, sustainable farmers that may continue to disentangle agriculture from climate change. In touching Imaginaries, we suggest soil imaginaries might be cultivated that are visceral and lively and exist on longer-term timelines than yearly crop rotations. Farmers are put in touch with soil health through visceral demonstrations by conservationists, which extend imaginaries of caring for soil to the ecosystems and microbiome beneath the farmer's feet. This encourages longer-term care and cultivation. In Posthuman Storytelling, we acknowledge how seed savers see agriculture as a story of human and more than human collaboration, and ask how SHCI might support these posthuman or co-shaping narratives of biodiversity, local agricultural histories, and care between people and plants. Finally, while intensified agriculture seeks to feed people by streamlining and efficiency, small farmers collectively are agile and curious about how to solve problems like climate change and sustainability. So how might agricultural technologies be designed to support curiosity and repair of both lands and communities, disentangling agriculture and climate change in grassroots in multiple ways?